Hello, in this video we will take a look at a feature of Azure Private Link called Azure Private Link Service. So if you look at the documentation of Azure Private Link, you can see that there's a few different concepts and the common concepts that people use with Azure Private Link is creating private endpoints to Azure PaaS services. For example, connecting to Azure Storage, SQL database, or other things. However, there is also a capability inside of Azure Private Link that's called Private Link Service. And Private Link Service is allowing you to build your own service, like a SaaS or a PaaS application that you provide to others, and how to expose that service to others, not via a public IP address, but via a private IP address in the consumer's Azure subscription. So if we take a look at what is Azure Private Link Service, this diagram kind of depicts the scenario. The scenario is on this side is you as the provider. You're the provider. You may be in your own Azure subscription in a specific region. You have a set of resources on virtual machines or virtual machine scale sets. And then you have a load balancer in front of it, standard load balancer it requires. And then you want to be able to let people, your customers, let's say you are a SaaS application, to be able to access your service. They can access it via public IP addresses today, just as a regular standard load balancer. But what if you wanted to give them a way to access your resources via private IP that's inside of the customers or the consumer's network, right? So what you could do is you could create this resource of type private link service, which is different than private endpoint, that will allow you to take the standard load balancer and make it possible for others, one or more of these customers, to connect here. There could be more than one customer connecting here. So during this video, we'll take a look at how this would work, and the documentation is pretty good. It explains everything clearly in this private link service overview page. It goes through and explains the flow, but we'll look at it in reality from a real deployment versus just the docs. So to get started, we will use this little repo directory. I put the directory called Private Link Service under my biceps example repo, and I put three deployment scripts there, three deployment templates that we will take a look at. One is for provider, two options, and one is for consumer. So what is this? It's basically for provider, there are two options. A public load balancer option, where the provider, you as the provider, as the SaaS ISV, for example, have your resources deployed and you're using a public load balancer. So that way there is public IP access to your resources, but you also want to be able to give a private link to that. So that's scenario one. And then scenario two, it could be you don't want any public access to your resources. You only want to be able to provide private access to your customers. You could use an internal load balancer. And later we'll also discuss how in a public load balancer case, you can provide both public, public, then disable the public and provide private only using network security groups. But let's say you know for sure you don't want to provide any public access, then you can right away deploy an internal load balancer and use that. So there's a few small tiny templates here that create a bunch of resources, and we'll run those and see how it all works. And once we deploy the provider, we'll also deploy a consumer, which basically will create a test VM from which we will be able to go and access the provider service. So let's begin. So first, let's create the public load balancer scenario. I cloned this little repo in my Visual Studio Code. I'm in the directory, private link service, and there is that README. So we'll go step by step and simulate the scenario. So step one, we'll create the resource group where we will put all of the resources so that it will be easier to look at all of them in bulk. So this will create a resource group. As a next step, we will create a deployment. And this deployment will take a few moments to run. While it's running, we will discuss what's inside of the template. So we'll just grab this deployment command, okay, and we'll invoke it. So I made it so that the template asks for a name parameter. We'll use it as a prefix for naming resources. So I will put avpls1 as the prefix. It will ask for the password for the virtual machines. And remember, this is just an example. It's going to use public load balancer in this case. And I think what it's going to do right now is just kick off the deployment. Okay, so the deployment kicked off. While it's running, let's go and take a look at the template that it's using. It's using this private load balancer template, main bicep. And inside of it, these are some of the parameters that I discussed. I'll go very quickly over the template because we'll look at the actual resources being created. So the deployment will use Ubuntu 2004 VMs. It will use 2 virtual machines because that's how many instances I ask for it to create. And what it will do is it will create a storage account for the diagnostics, virtual machine diagnostics. It will create a public IP address that will be attached to the load balancer. Note it must be a standard public IP because private link service requires standard load balancer. Okay, then it will create a network security group that allows, again, just for testing, SSH traffic on port 22 from anywhere, which is, don't do that in production, please. It will allow HTTP traffic on port 80, and just as an example, it will allow, let's say, 443 traffic for HTTPS. We were not going to test the HTTPS option. We'll just focus on HTTP, but it's there as an example. Then it will create a virtual network. Virtual network will have 2 subnets. It will have subnet 1 and it will have subnet 2. And the address spaces of each subnet will be very simple. So this is the virtual network address space, big one, just for test. This is going to be subnet 1 and this is going to be subnet 2. So you can see that 1 and that 2 over here in each subnet. We'll see why I created 2 subnets a little bit later. We'll also create a load balancer of type standard, obviously. And it says here, if you need to use private load balancer, this would be a private load balancer instead. We'll look at that example later. Front-end IP configuration, backend. We have a load balancing rule, load balancing port 80. We'll have an HTTP probe on port 80. We'll also have an outbound rule, so that way virtual machines can access the internet from behind the load balancer using the load balancer front-end IP. And basically that's what that allows, so communication outbound from the virtual machines. Then just for testing, so this is not really required at all for private link service, I'm creating an inbound net rule so I can SSH into the virtual machines so we can connect to them if we wanted to make some changes on them. But again, this is just a test, so don't do this for real. So you don't want to have a SSH access to your VMs behind load balancer, obviously. And then I'm creating the network interfaces, as many as their virtual machines. And each of them goes into that backend pool for the load balancer and goes into the inbound net rules. And then we're creating the virtual machines themselves, okay? From that image we discussed with the network interface, enabling the boot diagnostics with that storage account we created. And then as almost the final step, we'll install something on a virtual machine so that it's easier to test, right? Because virtual machine Ubuntu doesn't automatically have port 80 workload running. So what I'm doing here is using the custom script extension to run this installation script. And this installation script, for convenience, again, just as a very simple example, it's right in here, multi-line script for the installation. What it will do is it will install Nginx and it will configure it so it outputs the server address, the remote address, and the TCP proxy v2 address. We'll talk about TCP proxy v2 maybe in another video. But basically, when a VM gets deployed, it will run an update, install Nginx, back up the default config, and then it will override the config file with a very, very simple Nginx configuration, listening on port 80, not 443. Any request coming to the root will basically respond with content type text, will return status 200, and will respond back with this stuff. It will return server address, will return the remote address, so that's the server on which the request came, and then it will request the forwarded for address and some other information so we can see something, and then it will restart the Nginx. So that's the steps here. And very final, but the most important part of all of this is the private link service resource. We'll be creating private link service resource. Again, all of this can be created in the portal or other using Azure CLI or Terraform, but I'm showing it in Bicep just because it's easier to run it all in once without having many additional tools. So we basically are creating the private link service. We are not going to enable privacy protocol. Again, we'll talk about it maybe another time, what that is. It's not required. We'll put it to use the load balancer front end that we created, and we'll configure the IP configurations for netting, right? So as the requests will come in, so let's look at this diagram, as the requests will come in from the client to the private link service, there is special net that it will need to do because the IP addresses of the customer may overlap with the IP addresses of the provider. And therefore, the private link service will do magically a net. It will convert this IP address into one or more IP addresses that are configured for the private link service. Why do we want to have more than one? If we give it one, there is a limit on how many simultaneous ports it can have, because obviously every single IP from here will get converted into one IP here, and there's a limit of 64,000 ports on one IP or so, so there's a limit. So private link service for scalability allows us to specify up to 8 net IP addresses. So what I'm doing here is I'm configuring 8 net IP addresses, and each of the net IP addresses will come from dynamically assigned from that second subnet that I created. That's what I'm doing right here. Okay. And then there's some settings on the private link service to say who can use this private link service. For a SaaS provider, it's very common to say that if I have an alias of this private link service, which we'll see what that means, then any subscription can access it. There's different levels of access. I could do a specific subscription only here, or I can put everybody, like in this case. And final part is over here, you can see that the auto approval is nobody. So we made it so that it's a manual approval, and we'll see that workflow. When a consumer initiates the request, the provider can either automatically approve that request and establish the connection, or can prevent that and manually approve it. So you can see that described in this workflow. As you can see, step number 3, the service provider, it needs to approve, act, or reject, and we will see it in reality how it looks. So at this point, we'll go back and see if our deployment succeeded, and we can see that the deployment succeeded. Let's go and look at this deployment more in depth. So the deployment finished, and now let's come back to the provider subscription and see how it looks. If I look for private link, I can open up a private link center, what's called. And private link center again describes the common concept of private endpoints, which is what you would use to connect to Azure services. But this is what exposing your own private link service to others. If I click this button, I will be able to use the portal to create a private link service, but we already created one through that template, so we didn't have to click a lot in the portal. So let's look at the private link services. So you can see we have a private link service with 0 connections established because we don't have a consumer yet. So let's explore a little bit what this looks like. So we're going to go to the resource group that we created, RGPLS001. And inside of that resource group, we see all the resources we described, 2 virtual machines behind the load balancer. And the key part here, just to look at the load balancer, it has the front-end IP on the public side, because it's a public load balancer. It has the backend pool with the 2 virtual machines. It has the load balancing rule, load balancing port 80, and then that test only net rule for SSH. It's not relevant for a private link. This is just for testing SSH in case I need to connect to these VMs, and an outbound rule for outbound access. Okay, so let's take a look at the private IP address of the load balancer, because it's a private public load balancer. If I take this IP address and I browse there, we should be able to see the response from the Nginx that's running on one of the VMs. So let's look at the output. We saw this being created in the config of Nginx. This is the server address. So that's one of the nodes of the two nodes that I have running. So it looks like it's the node 1.5. This is my home address, let's say, or where I am running from right now, and it's forwarded to, and proxy protocol address not relevant for this discussion, that's for TCP proxy. But basically, I can access whatever this web application would have been. Right now, it's a fake Nginx responding with nothing. I can access it on public port. And as I obviously access it, it's accessible because the network security group, let's just take a look at the network security group that's attached to my subnet. It allows port 80 from anywhere. Okay. Let's say now we want to have a consumer who has an Azure subscription, right? So we're going to now go and simulate this situation. We're not going to look at the express route, obviously, but we'll create a consumer, and then we'll let the consumer connect to this private link service using private IP. So what we need to do for that is returning back to the repo. We'll skip the internal load balancer and we'll go to the consumer. We will deploy a test VM and a private endpoint connection to the provider. So in a completely different subscription, in a different Azure AD tenant, right here in Chrome browser, I have a completely different subscription, completely different Azure AD tenant, will be simulating my provider. And what I will do here, I already cloned the repo here inside of this example. So private link, and this is the repo with the bicep template. We're going to be deploying the consumer. So let's take a look and run command by command. So we'll create the consumer resource group so that we can create a virtual machine for testing, etc. So this is going to be the resource group PE. I call it PE for private endpoint 001 in West US2 region. Great. And then we're going to say to it, okay, let's create the consumer using the consumer bicep code. So we'll start that, and it will ask us for a couple parameters. Okay. So first thing it's asking, give me a prefix. So for naming resources, I'll call it AVPE private endpoint 1. It says, give me a password for the VMs, or for the VM in this case. And then it says, give me private link service ID, right? So it will need to establish the connection to private link service. But how does it know? There's maybe many providers in Azure, provider 1 through provider 1,000, with different companies using private link service to provide access. So each private link service has what's called an alias, and the documentation explains what the alias is like, but let's look at it in real. So if I go to my private link service right here, and I look right over here, this is my private link service alias. So this is the string it's asking for. So as a provider, after creating private link service, you would need to give this string to any consumer that needs to be able to establish private link connection to this service. This is an alias, and it's done in a way where it has part of the name right here, right? You can see this is the name of the private link service, but then there is a GUID and a region and Azure Private Link Service. It does not have your subscription ID in case you don't want them to know what subscription your service is running in. So let's go to the deployment here and just give it that ID and say go. So this will take a few moments to run, but while it's running, let's explore the template that the consumer is using. What's inside of the consumer template? It's a very simple template again. It's going to create, again, a Ubuntu virtual machine. It will not do anything, not install Nginx there because this is a consumer just to pretend the client will use curl to interact with the provider. It will have a storage account for boot diagnostics and stuff like that. Public IP address will be attached to that client, so I can SSH into it. Just an SSH open virtual network where the where it will live. And notice I on purpose will use a completely different address space here so we can distinguish consumers from producers easier, but it's not required. The address space could be overlapping, but just for simplicity, for easier to see, I will use the different address space. So virtual network gets created. There are some requirements such as private network and policies disabled property on a subnet where we're using private link. That's documented, but that's when you do it in the portal, it automatically does it. But here I'm doing it in a template, so I have to. It creates a network interface, creates a virtual machine, and basically then it runs the extension, which installs nothing. And then it creates the private endpoint. So instead of creating private link service, it's creating private endpoint. So what is the private endpoint? It is basically this resource right over here, right? So we just created the virtual machine, and now we're creating this private endpoint. So let's look at the private endpoint definition. We give it the location, and we say manual private link service connection. It will have a name. We give it a name. We define the name above. We give it that private link service ID that was a parameter that we requested, and we request message. What is this request message? It's a variable that will simply inside of it have my test private link service connection with the name, right? So just some message that could be passed from the consumer to the provider. Okay, so again, this is the public access. Public access still working just fine. This is the public IP address, so I can access it like that, or I can access it on the public IP address on the IP, just to make it clear that it is an IP and not a domain. Let's put that here instead, right? So same thing. So this is still public. Private, as soon as client gets deployed, we'll take a look. And one final thing before we look at the client is just to glance at the private link service resource here, what we have. The access security setting, remember, we marked no auto approval subscriptions. That's why this list is empty. We will need to manually approve everyone. But who can use my private link service? I put a star in there. And this is why it says anyone with your alias, because for a third-party access, if I don't know their subscription, could be many, I put in anyone with an alias. That's controlled by that, by this code. So inside of the public load balancer section right here, we can see it being controlled right over here with this star visibility. And there's different ways to configure this visibility. So now just looking back at our deployment of the consumer, looks like it finished deploying. We can explore the resource group it created. And inside of that resource group, we see our private link endpoint, private endpoint. And we also see the public IP address of the VM that we created. So let's take the public IP address of the VM we created and SSH into that VM so we can do some testing. So we open up SSH session this is the consumer. I just gave it a random name. Got this error because I previously connected to it. I needed to clear the host keys in my SSH. Okay, so I'm on the client now. So what is my IP address? This is my IP address on the client, 172.16.1.5, because I'm on a client in a completely different subscription, a completely different Azure AD tenant, right? So now from this client, okay, I can still obviously access the provider using the public IP address. Let's just see what that looks like. So if I do curl to this endpoint, you can see a response came back. Sorry, it doesn't look pretty, but it's coming back. It says I was able to reach that Nginx server, and it's seeing this 52 IP address, right? So what is this, the remote address of my client? This remote address of my client, if you notice right over here, is the same, right? Because that is the public IP of the VM, of the client. So when a client VM in the consumer side making requests to the public endpoint, nothing special here. There's no private link involved, right? So this is no private link involved. We see public IP being used to access. Great. So let's minimize this session. And now let's go back into our private link endpoint and explore it a tiny bit on the consumer side. What do we have? So on the consumer side, we have a private endpoint that we created, and a private endpoint is linked to a private link resource, PLS, AVPLS1. Obviously, this resource does not live in my subscription. It lives outside. We see it's in a pending state. We'll talk about what that means. And we also see this response and request message, my test private link service connection AVP1. You saw it in the template I just filled in. But your customer could be asked to provide some specific state information or some ID or something like that for you when they're establishing a private endpoint connection. So it's pending. What does it mean pending and why it's pending? So we're going to go back to the consumer side. Okay, and we're going to click on the private endpoint connections. And we're going to see that on the consumer side, our private link service has a pending connection. And over here is the private link endpoint, private link endpoint ID. So 5429. And if we look here, this is going to be what it's representing right here. This is that private endpoint connection, this one. And you can see the messages pass through private endpoint ID, and it's a pending state. So as a consumer, because I did not set up auto approval on the provider side, the provider now has to act on the request to approve it or reject it. It's obviously possible to do it completely automatically through calling an API to approve or reject, but just for simplicity, in the portal, if I click this approve button, it's actually calling the approval API or approval CLI. There are CLI commands to do this approval as well. So if I click the approve button, and I can change the message, but I'll keep it the same, it will take a second to do the. And just to show that the CLI command to do the same approval as I just did in the portal is Azure Network Private Link Service Connection Update, connection status approved, reject, or removed, right? So in this case, I just did it in the portal instead. Okay. Next step will be to see if it says approved. So it says approved on the provider side. Let's see what it says on the consumer side. It also says approved. Great. Let's see one more place. If we go to Private Link Center here and click on Private Link Services, we see there's one connection that got approved, and we can see there's the Private Link Service that's currently approved between to this connection. If I click it, I can see which one was approved, right? So that's basically the steps. Now, this window, I'm on the client, on my client, right? IP address, and you can see it's my client in a completely different subscription. Let's see how can it talk on the private link to the same thing we talked to on the public IP. Okay, so what is the IP address of this private link endpoint? So private link endpoint created a network interface for itself right here, and I can discover this using CLI commands. But I can also just click in a portal and see it. So this is the private IP address of the private endpoint. Another way to see it, as an example, is if we go to our virtual network and look at the connected devices, we have the virtual machine itself, and we have that private endpoint that got created, okay? So what if we try to access HTTP port 80 on that private endpoint? This may take a few seconds to establish that first connection, first net, and then we should be able to see the response. We saw that the response came back immediately, actually. Didn't delay for a second. Sometimes it takes a second if you do this, or a few seconds. But let's see, let's analyze this response. So we made a request to 172.16.1.4, and this is private link endpoint. There's no virtual machine that responds with this information in the consumer side. Rather, it's coming from that Nginx cluster that we deployed in the provider side. And it's responding back and saying, hey, this is the IP address of the server. So it's one of the virtual machines on the provider side. And notice this IP address. This is the most interesting part. You see this IP address as 10.024, okay? So let's pay close attention. This is here. What is the client itself from which I'm making the request? It's 172.16.1.5. So what is happening right over here is the net through Private Link Service. So Private Link Service converts every client's IP into an IP that can access that's what is visible to my code running, in this case, Nginx. Where is this IP coming from? So just to remind ourselves, it's coming from the net configuration of the private endpoint. Right here, we told it, grab IP addresses from this subnet 2, and subnet 2 has 10.2.4, .5, .6, .7. Remember, I mentioned I added 8 of them up to maximum of 8 on purpose. So if there's a lot of simultaneous connections from the client, each of these IPs will provide up to 60 something thousand ports. And you can see in this case, the IP that we see is the .4. So it's this netted IP address. So what my code is seeing, meaning if I was running this as my custom code and I was looking at the remote IP address of the customer making a request, I would not really see their IP address, because from the public internet, I do see the IP address because it's coming in like that in a remote address header. But when it's coming through private link, I'm getting a netted IP address, as this diagram over here shows. There's this netting happens, and I'm getting an IP address of the net device. So if my code is sensitive and it needs for some reason to know this private IP address, first of all, it's kind of relatively not useful because it's a private IP, which can overlap with my own anyways. Um, I'm not getting it here. I can make some changes and make it appear inside of the proxy protocol variable, and we'll discuss it later. And that's what's called this proxy v2, TCP proxy v2. That's what that feature is for. But we on purpose disable that feature. We disable that feature over here on purpose because that feature is more advanced, requires some configurations that we can discuss another time. And basically, in this case, I am running my private link service, and I can access the public load balancer both ways. I can access it publicly, but I can also access it privately once the connection is established. And if just for convenience, for example, if I still can access it publicly, right? Because I did not make any changes. So check this out. It will access it through the public endpoint. But notice in this case, I'm getting obviously the public IP address of my VM. And in this case, I'm getting the netted address. Great. What if I wanted to then say, look, let's not allow any access from this public side, but only from the private side? What are my options? So there are going to be a couple options for that, and we'll cover it next. So one option we have to prevent public access to this is described in the repo. Let me just show you. Is instead of creating a public load balancer for this load balancer that has a public IP, we could have right away created a internal load balancer. And if we created an internal load balancer, the template is extremely similar. The only difference would be that when we create the private load balance, the load balancer, our front end IP right here would be coming from a subnet and not be using a public IP address. It would be internal only load balancer. So this example we can try deploying later, but it also deploys a few other resources for convenience. It explained right here. It creates an Azure Bastion for SSH access and a VNet gateway for outbound access, because if it's an internal load balancer, then my virtual machine cannot go out without a NAT gateway of some sort. and it puts Linux VMs behind it. So while we're going to be looking at the other option, let me kick off this deployment so we can review it. So I'm going to just create another um, resource group here. So this one was PLS 001 for public load balancer. Let's deploy the private one. It takes a few minutes, but just so that everything is super clear here, let's kick it off. So we again specify the name. In this case, it will be 2 and a password. And this deployment will take some time. So that's one option. We can create an internal only load balancer here. Great. But what if I wanted to have public one and switch it to private one, right? Can it be done? It cannot be really done, right? You cannot take a load balancer right here that has a front-end IP already. Its front-end IP right now is public. I cannot easily change this load balancer to private. I could delete it and create a new one, but I cannot switch it to private anymore. What I can do though, relatively easy, is because I have this network security group, this network security group is attached to a subnet, right? So if I look at which subnet it's attached, in my template, I attached it to both of these subnets, okay? And remember, for this private link service, I configured net. And we saw that the client right here, right, when it was accessing the endpoint, it's coming in on that net. So this is public IP, this is private IP. So let's clear screen here and just glance at it again. So my VMs are seeing requests coming in from 10.0.2.4. Why that 2.4 is because that is the net IP. So I know this subnet is where the requests were coming. So what I could do is I could keep the public IP on the load balancer in theory, and I could go into my network security group and change the rule for, instead of any here, I could restrict it. And I could say, you know, I'm only going to allow access from 10.0.2.0.24 because this would be the range where the net devices are. Or I could say .4 and put in, you know, additional IP addresses there like that, right? There's 8 of them. So for now, I'm just going to say 24, right? So all of that subnet. Trust all of that subnet and save it. So now we're locking down our NSG on this public load balancer to allow port 80 traffic only from these IPs. So once this network security rule is applied, if I refresh this after it's applied, it will stop working. So let's give it a second for it to apply, and then we will see. So if we try it again now that we added the network security group, once it got applied, we can see it does not work anymore to access it through the public endpoint. And also, even if this is that client VM, if we do a curl, we cannot access it, right, anymore publicly. We cannot access it this way publicly, and we cannot access this way publicly anymore because we added a network security group. Basically, what's blocking it, the load balancing rule is still there. The load balancing rule is still there, port 80, but the NSG is preventing access. This NSG is preventing access. But what about now, can I still access it on a private IP? So let's go to the client VM and try it. And yes, we can. We are able to access it still on the private IP because the private IP requests will get netted and NSG is allowing it. So in essence, I could have started with a public load balancer, and instead of recreating it using internal load balancer, if it's okay for my perspective to have a public IP but just not make it possible to use, I could have network security group that blocks traffic. In this case, I'm not using port 443, so that's why I didn't change it, but it obviously would need to do the same, and says only allow requests from these IPs, and that means it came from the private link service because the subnet is used for private link service IPs. And now just to finish off the discussion, it just deployed the other scenario of the internal load balancer. Let's just finish looking to see if that worked. So if we look at private link services, we're now going to have two, right? One is that private public one we did. This is the private one. Let's look at the resource group and everything that got created. We created a bastion because there is no public IP attached to the VM load balancer. So if you look at the load balancer for the second one, right, notice it's subtle change. It's just PLS2. If I click on front end, you can see the front end is only coming from a subnet, right? It's coming from a specific subnet and not public. So there's no way to access this from the outside. But because we have the have the bastion, we can connect to the VMs, etc. But how could we connect to this private endpoint? Now, the only way is to establish the private endpoint connection to this private link service. So what we're going to do now is use the portal to create a private endpoint connection. We're going to copy the alias of the private link service. We're going to go to the consumer and we're going to say, I want to create, just to show how it's done in the portal, another private link endpoint, private endpoint, create, and it says, okay, where do you want to put it? We're going to put it under same resource group. We're going to call it AVPE2, private endpoint 2. It's in the West US where the virtual network is. Connect to an Azure resource in my directory. Nope, it's not what we want. Connect to an Azure resource by resource ID or alias, and that's what we do want. We got the alias. We're going to put a message here. This is me creating a connection private link endpoint today 2022-0303. Okay, so this message will be visible by the provider. I'm going to say virtual network, where to put it, same virtual network where we have the other endpoint. Notice that the DNS does not automatically integrate with these types of private endpoints, unlike Azure PaaS services. I'll explain the DNS in a second, but basically you need to create your own DNS record in your own DNS server or in the Azure DNS private zone to resolve these IPs that private link gets. I will explain in a second, and we'll say create. So let's see what happens. So we'll say create, and this will kick off. And while it's doing that, let's discuss for a bit what I mean by the DNS. So on the consumer side, let's look at this resource group. On the consumer side, there is a private link endpoint 1 that we already have, and it has a certain IP address. This IP address is static. It will not change because this private link endpoint exists already, and it will be there for this private link endpoint. This is the way to access that service, right? That's how we access it. Many times your service will require a domain name. You cannot use, IPs because there is an SSL certificate or other things. How would you make this a domain name? It is up to the consumer. That's the key. They would need to take this IP address and add it to their DNS. Maybe they already have a DNS running or have a Azure private DNS zone created. And then it all depends on the consumer preference, and put there an A record that maps some host name to this private IP. And the final option, as a provider, you could have a public DNS record zone where you can create, but you would need them to give you this number. You as a provider do not know this number unless the consumer gives it to you. So for DNS, there is that step, creating a DNS to point this. The main thing you get is a static IP, but no DNS gets created automatically. So it looks like it finished creating my second private endpoint. So let's see. Created that second endpoint. If I click on it, it's pending. Let's go to the provider side. And this one is actually connecting to our, second deployment that we had with the internal load balancer only. If we click here, we can see pending endpoint with that message that I put in, right? I can say approve, give it a minute. And once it's successfully approved, on the client side and the consumer side, we should also see approved, okay? And then we should be able to see that this IP will be different, obviously, because in the same network, we already have two private endpoints. So let's see if we can make a request to this one. And we can make a request to this one. And it looks like it's responding with the same thing. Well, because my private load balancer, internal one and non-external one happen to have the same network address space, so everything looks the same. So just to make sure that this works correctly, everything is talking to the right thing, we can go and see, okay, so it's right now I'm connected to virtual machine with this IP address on the provider side, and that virtual machine on the provider side is this one. So it's the VM PLS2. Let's do a quick connect to it using Bastion just to test this anyway. So we'll connect because we deployed the template in the example deploys Bastion. Okay, and then we'll go sudo. We'll go to Nginx. We'll do a quick edit of this Nginx thing so we can see it better. And we'll put here internal load balancer example, just as an example. Okay, we'll save it. We'll restart Nginx. We'll confirm that it's working locally, okay? And now we'll go back here and we'll make a request. Oh, now it hit another endpoint, so we just have to do the same change on the second VM. That's what happens when you have a load balancer in place. You never know where you're gonna go. So let's do the same thing on both. So connect, become root, edit, and then we'll put here internal load balancer example. Okay, restart Nginx because we changed the config. Okay, do a local test. Okay, so locally it works. Let's go to the client VM, make a call, and we can see when we call .6, we're hitting the internal load balancer example. When we're hitting .4, we're hitting that previous public load balancer example, but only on the private side. So that's basically it for this video. Just to recap and conclude, we discussed what this Azure Private Link Service is. We deployed a provider, both ways, private load balancer using internal load balancer and using public load balancer with network security group if needed, and the consumer. And we tried creating, multiple endpoints and such. In the other video, if I have a chance, I'll describe how to use the proxy protocol v2 uh, to be able to interpret, to get the IP address of the client that's making the request, this one, how to get this IP to be passed. But it's not usually required, so if you don't need it, this is all you need to know. Thank you. Hopefully this was useful.